Picture this. It's 1973, and the government just handed down regulations that should have killed American muscle cars forever. Every manufacturer was scrambling to meet emission standards, slashing compression ratios, and watching their horsepower numbers plummet like stones. Except one company decided to flip the automotive world the bird. Pontiac engineers, in what can only be described as an act of beautiful rebellion, created an engine so outrageously powerful that it made the EPA's new rules look like suggestions. This is the story of the 455 Super Duty, the last true muscle car engine, and quite possibly the most defiant piece of automotive engineering ever bolted into a production car. But here's where it gets interesting. While everyone else was detuning their engines to meet federal standards, Pontiac was secretly developing something that would embarrass supercars 40 years later. They weren't just building an engine, they were crafting a middle finger cast in iron and aluminum. The 455 Super Duty wasn't just another big block V8. This was Pontiac's nuclear option in a war they knew they were going to lose, and they were going to lose it spectacularly. To understand why this engine matters, we need to travel back to the early 1970s. The muscle car era was dying, insurance rates were through the roof. The Clean Air Act of 1970 had just kicked in. Compression ratios that had been climbing throughout the 60s suddenly hit a wall. GM had issued a corporate edict. No intermediate car could have an engine larger than 400 cubic inches. The party was over. Or was it? Pontiac found a loophole. The ban was on engine size, not on making that engine absolutely mental. If they couldn't go bigger, they'd go harder. The plan was simple in concept, insane in execution. Take their existing 455 block and turn it into something that belonged on a drag strip, not a dealer lot. The development started in 1971 in Pontiac's secretive engineering department. The team, led by engineers like Herb Adams and Bill Collins, knew they had maybe 2 years before everything would be strangled by catalytic converters and unleaded gas. They had one shot to create something legendary. Here's the thing about the Super Duty program. It wasn't supposed to exist. GM's brass would have killed it instantly if they knew what Pontiac was really building. So the engineers did what engineers do best. They lied creatively. On paper, they were developing an emissions-compliant performance option. In reality, they were building a race engine with license plates. The foundation was Pontiac's 455 cubic inch block, but that's where the similarities to the standard 455 ended. Every single component was either heavily modified or completely redesigned. The block itself got 4-bolt main bearing caps on all 5 journals. That alone was unusual. Most performance engines only used 4-bolt mains on the center 3. Pontiac wanted zero flex, zero movement, zero excuses. The cylinder heads were masterpieces of airflow engineering. Using what Pontiac called SD heads, they featured massive 2.11-inch intake valves and 1.77-inch exhaust valves. The ports were so large that Pontiac engineers joked you could drop a golf ball through them. These weren't just big, they were scientifically optimized using flow bench testing that was revolutionary for the era. Each port was hand-finished at the factory, by hand. In 1973, the camshaft was pure violence. With a duration of 301 degrees on the intake and 313 on the exhaust and 520 inches of lift, this thing had more overlap than a Venn diagram convention. At idle, it sounded like the engine was trying to escape from under the hood. The lope was so aggressive that Pontiac had to recalibrate their assembly line equipment because the engines kept stalling during the production process. But the real secret weapon was the bottom end. Pontiac specified forged aluminum pistons from TRW. These weren't just any forged pistons. They were designed specifically for this engine, with a unique dish configuration that gave exactly 8.4.1 compression with the SD heads. Low compression for emissions? Sure, if you ignore the fact that these engines were designed to run on 91-octane regular and still make power that embarrassed high-compression engines running on 103-octane racing fuel. The connecting rods were forged steel, shot-peened for strength, and fitted with 7/16-inch cap screws instead of the standard 3/8-inch bolts. The crankshaft was a nodular iron piece that was so overbuilt it could handle twice the power the engine was rated for. Pontiac knew exactly what customers were going to do with these engines, and they built them accordingly. Now here's secret number one that Pontiac never advertised. The Super Duty was underrated from the factory, way underrated. Officially, it made 290 horsepower and 390 lb-ft of torque. Those numbers were comedy. Independent dyno testing showed these engines making 370 horsepower and 460 lb-ft at the wheels. That means the actual flywheel numbers were closer to 425 horsepower and 500 lb-ft of torque in 1973. During the supposed death of performance, the oiling system was another piece of hidden genius. Pontiac used a high-volume oil pump, a deep-sump oil pan with baffles to prevent oil starvation during hard acceleration, and an external oil cooler that was mandatory, not optional. The oil passages were enlarged throughout the engine. This wasn't just about lubrication, it was about heat management. These engines were expected to run at full throttle for extended periods. The intake manifold was an aluminum dual-plane design that looked pedestrian but flowed like a hurricane. Pontiac's engineers had spent hundreds of hours on the flow bench optimizing the runner length and plenum volume. It was matched to a Rochester quadrajet carburetor that was specially calibrated for the SD engine. The carburetor alone had 17 different modifications from the standard quadrajet, including richer jets, a revised secondary air valve, and special metering rods. Here's where things get really interesting. Pontiac installed what they called a ram air system, but it wasn't your typical ram air setup. The hood scoops weren't just decorative. They were functional, feeding cold air directly to the carburetor through a sealed air cleaner assembly. But here's the clever part. The system had a vacuum-operated valve that would close the outside air source at idle and low speeds, drawing warm air from around the exhaust manifold instead. This helped the engine pass emissions tests. At full throttle, the valve would open, and suddenly you had true cold air induction. It was brilliant engineering disguised as emissions compliance. The exhaust system was equally clever. Pontiac fitted special exhaust manifolds that were essentially headers wearing a disguise. They featured longer primary tubes than standard manifolds and better collector designs. They flowed so well that many racers didn't even bother swapping them for aftermarket headers. But wait, there's more. Pontiac knew these engines would be raced, so they included things that made no sense for a street engine. The harmonic balancer was a heavy-duty unit designed for sustained high RPM operation. The flywheel was lightened and balanced to tighter tolerances than Pontiac's regular production engines. Even the motor mounts were special heavy-duty units designed to handle the violent torque this engine produced. The testing process for the Super Duty was unlike anything Pontiac had done before. Every single engine was run on a dyno at the factory, not just a sample from each batch, every engine. They were run through a break-in procedure, then subjected to a full power pull to verify they met specifications. If an engine didn't make the power target, it was torn down and rebuilt. This was unheard of for a production engine in 1973. Secret number 2. Pontiac built special tools just for these engines. There were unique tools for setting valve lash, special fixtures for assembly, and even a specific torque sequence that was different from other Pontiac engines. The assembly line workers who built these engines received special training. It was like Pontiac was building race engines on a production line. The durability testing was savage. Pontiac ran these engines at wide-open throttle for 100 hours straight. They thermal cycled them from 40 to 240 degrees Fahrenheit. They over-revved them to find the failure point. One test engine was run at 7,000 RPM for 24 hours straight. It didn't break. The engineers actually had to intentionally damage components to find the weak points. Here's something Pontiac never told anyone. They developed 3 different versions of the Super Duty. The production version we know was actually the mild one. There was a prototype that made over 500 horsepower with different cams and higher compression. There was even a twin-turbo version that was tested in secret. That engine reportedly made over 700 horsepower, but was deemed too expensive to produce. The Super Duty found its way into just 2 models, the Firebird Formula and Trans Am, and the Le Mans-based GTO. But here's secret number 3. Pontiac built 50 special Super Duty engines that were never installed in cars. These were sold as crate engines through their parts department, but with a twist. They came with different camshafts and valve springs designed purely for racing. These engines were essentially factory race motors that bypassed GM's ban on factory racing support. The production numbers tell a story of their own. In 1973, Pontiac built just 943 Super Duty engines. In 1974, before the engine was killed off, they built only 943 more. Total production, 1,886 engines. But here's the kicker. Pontiac actually cast enough components to build 5,000 engines. The leftover parts were quietly sold through their performance parts network for years afterward. The performance was staggering for the era. A 1973 Trans Am with the Super Duty and a 4-speed manual could run the quarter mile in 13.8 seconds at 104 microMHz. With slicks and a tune, 12-second quarters were easy. This was when most performance cars were struggling to break into the 15s. The Corvette's 454 big block was making 275 horsepower. The Super Duty embarrassed it. But Pontiac wasn't done with secrets. The 4-speed manual transmission available with the Super Duty wasn't just any manual. It was a special close-ratio M22 rock crusher, Muncie built specifically for this application. The gear ratios were selected to keep the engine in its power band during drag racing. The clutch was an 11-inch heavy-duty unit with a special pressure plate that could handle the torque. Even the automatic transmission option was special. The Turbo 400 that came with the Super Duty had unique internals. The torque converter was a high stall unit that wouldn't lock up until 2,800 RPM. The valve body was recalibrated for firmer shifts. The transmission cooler was larger than standard. Pontiac even used a different transmission mount to handle the additional stress. The cooling system was overbuilt to an absurd degree. The radiator was a 4-row unit with 20% more capacity than the standard 455 engine. The water pump was a high-flow unit. The fan was a special 7-blade design that moved more air but was balanced to prevent vibration at high RPM. The thermostat was even special. It opened at a lower temperature to keep the engine cooler during performance driving. Here's secret number 4 that's truly mind-blowing. Pontiac hid performance parts in the trunk of every Super Duty car. Under the spare tire, wrapped in Cosmoline, owners would find a set of header bolts, different carburetor jets, and instructions for off-road use only modifications. It was Pontiac's way of saying, "We know what you're going to do with this car, so here's some help." The suspension on Super Duty equipped cars was also modified, though Pontiac never really advertised this. The springs were specifically rated for the engine's weight and torque output. The front anti-roll bar was thicker. The rear control arms on Trans Ams were boxed for additional strength. Even the drive shaft was special. It was larger in diameter and balanced to tighter tolerances. But perhaps the most incredible secret was the engine's computer. Wait, computer? In 1973, yes. The Super Duty had what Pontiac called an electronic control module that monitored engine temperature and adjusted the ignition timing accordingly. It was primitive by today's standards, but it was one of the first production applications of electronic engine management. It could retard timing by up to 10 degrees when it detected detonation. The development cost of the Super Duty program was staggering. Internal documents that surfaced years later showed Pontiac spent nearly $3 million developing this engine, roughly $20 million in today's money. For an engine they knew would only be produced for 2 years. The per-unit development cost was higher than some entire car programs. Secret number 5 involves the engine's end. The Super Duty wasn't killed by emissions regulations or insurance companies. It was killed by GM corporate politics. Executives were furious when they discovered what Pontiac had built. The engine was making their corporate Corvette look bad, and that was unacceptable. The order came down, kill it immediately. But Pontiac engineers had one last trick. Before the program was shut down, they documented everything, every specification, every test result, every modification. They created what they called the Super Duty Bible, a comprehensive manual that detailed exactly how to build and modify these engines. Copies were quietly distributed to select Pontiac dealers and racing teams. The racing success of the Super Duty was immediate and dominant. In NHRA stock eliminator, Super Duty cars were virtually unbeatable. They were so dominant that the NHRA actually created special rules to slow them down. Weight penalties, restrictive carburetor rules, even mandatory gear ratios. Nothing worked. The Super Duty cars just kept winning. Professional racers discovered the engine's true potential quickly. With basic modifications, headers, cam, and carburetor work, these engines were making 550 horsepower. With serious work, 650 horsepower was achievable. Remember, this was from an engine designed to pass 1973 emission standards. The street racing legend of the Super Duty was even more impressive. In Detroit, New York, and Los Angeles, Super Duty cars became mythical. They were the cars that nobody wanted to race. Stories circulated of Trans Ams with mysterious SD455 badges, destroying everything from Hemis to 454 Chevelle. The engine developed a reputation. If you saw those badges, you didn't race for money. Here's secret number 6. Pontiac built 12 experimental Super Duty engines with aluminum blocks. These engines were 150 pounds lighter than the iron versions and were tested in specially prepared Trans Ams for possible use in Trans Am racing. They made the same power but completely transformed the handling of the cars. All 12 engines were supposedly destroyed, but rumors persist that at least 3 survived. The aftermarket support for the Super Duty was unprecedented. Within months of the engine's release, companies were offering everything from forged internals to complete cylinder heads designed specifically for the SD. Pontiac had secretly worked with several aftermarket companies during development, sharing flow data and specifications. It was a backdoor way to support racers without officially supporting racing. The engine's weakness, yes, it had one, was the valve train at sustained high RPM. The stock valve springs would start to float around 6,500 RPM. But here's the thing. Pontiac knew this and included the exact specifications for replacement springs in the owner's manual. Not the shop manual. The owner's manual that came in the glove box. They literally told owners how to make the engine rev higher. Secret number 7 is about the fuel system. The Super Duty required premium fuel, but not for the reason you'd think. The engine would run on regular, but Pontiac discovered that premium fuel's better detergent additives were necessary to keep the huge carburetor clean. Running regular gas would cause the carburetor to gum up within 3,000 miles. Pontiac never explained this publicly, leading to many warranty claims from owners using regular gas. The exhaust note of the Super Duty was unlike any other Pontiac engine. At idle, it had a distinctive offbeat rumble caused by the camshaft's overlap. At full throttle, it produced a sound that one automotive journalist described as mechanical thunder. Pontiac actually tuned the exhaust system for sound, using specific pipe diameters and muffler designs to create what they internally called the Super Duty sound signature. The truth about the horsepower rating gets even more interesting. Secret number 8. Pontiac had 2 different dyno rooms for the Super Duty. One was set up to EPA specifications for emissions testing. The other was set up for what they called development testing. The development room had cold air ducted to the carburetor, used racing fuel, and had optimal atmospheric conditions. In that room, stock Super Duty engines routinely made over 400 horsepower. The Super Duty's influence on future engines was profound but hidden. The flow bench data Pontiac generated during development became the foundation for performance cylinder heads for the next 2 decades. The cam profiles developed for the SD were copied and modified by cam manufacturers. Even the oiling system modifications became standard practice for building performance Pontiac engines. Here's secret number 9 that's particularly fascinating. Every Super Duty engine had a hidden serial number. Beyond the standard engine code and VN derivative, there was a third number stamped in a location known only to Pontiac engineers and select dealers. This number traced back to the specific engineer who assembled and tested that engine. It was Pontiac's way of tracking quality and privately taking pride in their work. The international story of the Super Duty is largely unknown. Pontiac quietly exported 50 Super Duty engines to Australia for use in Holden race cars. Another 30 went to South Africa. These engines were technically illegal to export due to their emissions non-compliance, but they left the country as industrial equipment. 20 engines went to Mexico for use in the Carrera Panamericana race. The dealer network had its own secrets. Select Pontiac dealers were given special training on the Super Duty. They received tools, modification instructions, and even spare parts that weren't in the official parts catalog. These dealers became known in racing circles as SD dealers. If you knew which dealers to visit, you could buy parts that officially didn't exist. Secret number 10 involves the original design target. The Super Duty was initially conceived to make 550 horsepower and be sold as a pure race engine, similar to Chevrolet's ZL1 427. GM killed that plan, so Pontiac engineers reverse-engineered a street version that could be detuned to pass emissions while retaining the race engine's fundamental architecture. Every Super Duty was essentially a detuned race engine. The cost of the Super Duty option was $675 in 1973, about $4,500 today. But here's what Pontiac never told buyers. The actual cost to build the engine was over $2,000 per unit. Pontiac lost money on every Super Duty they sold. They considered it a marketing investment, a way to maintain their performance image as the muscle car era ended. The testing procedures went beyond just dyno runs. Pontiac put Super Duty-equipped cars through what they called journalist abuse testing. They gave pre-production cars to automotive journalists with instructions to break them if you can. The cars were drag raced, road raced, and generally tortured. One journalist performed 50 consecutive full-throttle quarter-mile runs. The engine didn't even overheat. Here's secret number 11. The Super Duty was originally planned to get fuel injection. Pontiac had developed a mechanical fuel injection system similar to Chevrolet's Rochester unit, but flowing 30% more fuel. It made 475 horsepower, but was deemed too complex for production. 3 prototype injection systems were built. Their whereabouts remain unknown. The assembly process included something unique. Every Super Duty engine was signed by its builder. Not officially, the assemblers would use a paint pen to sign their initials inside the valley cover. It was their way of taking ownership of their work. Years later, when rebuilding these engines, many owners have found these signatures and tracked down the original builders. The racing modifications Pontiac developed but never released were extensive. There were experimental titanium connecting rods that weighed 40% less than the steel units. There were cylinder heads with welded-in ports that flowed 20% more air. There was even a dry sump oiling system that was tested but never produced. All of these parts were destroyed when the program ended, officially. Secret number 12 is about the transmission calibration. The automatic transmission's shift points were secretly adjustable through the carburetor linkage. By changing the geometry of one bracket, something that looked like normal adjustment, you could raise the shift points by 1,000 RPM. Pontiac included instructions for this in a technical service bulletin that was only sent to specific dealers. The truth about emissions compliance is hilarious. The Super Duty technically passed the 1973 emission standards, but only under very specific test conditions. The engine had to be at exactly 180 degrees, the ambient temperature had to be between 60 and 85 degrees, and the test had to be performed at sea level. Any deviation, and it would fail miserably. Pontiac knew this and made sure all EPA testing was done under ideal conditions. The carburetor had 13 different circuits, making it one of the most complex carburetors ever fitted to a production car. It had primary and secondary metering systems, an adjustable air valve, multiple accelerator pump circuits, and even a high-altitude compensation system. Pontiac engineers joked that it was more complicated than the Apollo spacecraft's fuel system. Here's secret number 13 that involves corporate espionage. Ford bought 3 Super Duty engines through shell companies and completely disassembled them for analysis. They were developing their own 460 Super Cobra jet and wanted to understand Pontiac's approach. Internal Ford documents called the Super Duty the most thoroughly engineered production performance engine ever built. The bearing clearances were revolutionary for a production engine. Pontiac specified clearances that were tighter than most race engines of the era. This required special assembly procedures and temperature-controlled assembly rooms. The tight clearances improved oil pressure and reduced internal friction, but required precise machining that pushed their manufacturing capabilities to the limit. The Super Duty's camshaft was so aggressive that it actually caused problems on the assembly line. The vacuum at idle was so low that it wouldn't operate the power brake boosters during the assembly process. Pontiac had to install special auxiliary vacuum pumps on the assembly line just to move the cars from station to station. Secret number 14. There was a marine version of the Super Duty. Pontiac quietly developed a version for boat racing with different cam timing, a special cooling system, and reinforced internals for sustained high RPM operation. 12 engines were built and sold to select racing teams. These engines dominated offshore powerboat racing for years. The quality control was obsessive. Every crankshaft was X-rayed for cracks. Every connecting rod was magnafluxed. Every piston was individually weighed and matched into sets with less than 1 gram variation. The cylinder heads were flow tested, and any head that didn't meet the minimum flow standards was rejected. The rejection rate was nearly 20%. The Super Duty influenced emissions testing procedures. After discovering how Pontiac had gamed the system, the EPA changed their testing protocols to include varied temperatures, different altitude simulation, and longer test cycles. The Super Duty literally forced the government to write new rules. Here's secret number 15 about the mythical Phase 2 Super Duty. Pontiac was developing a 489 cubic inch version using a longer stroke crankshaft. This engine made 520 horsepower and 600 lb-ft of torque on the dyno. 3 complete engines were built before the program was canceled. GM ordered them destroyed, but persistent rumors suggest one survived in a private collection. The dealer preparation of Super Duty cars was extensive. The official prep instructions included adjusting the carburetor, setting the timing to specifications different from the factory manual, and even changing the spark plug gap. Dealers were essentially doing a mild tune-up to unleash more power while maintaining warranty coverage. The Super Duty's legacy in Trans Am racing is hidden but significant. While Pontiac never officially raced the Super Duty in Trans Am, privateer teams did, using destroked versions to meet the 305 cubic inch limit. These engines dominated until they were specifically banned. The SCCA actually wrote a rule specifically excluding the Super Duty architecture. Secret number 16 involves the oil itself. Pontiac specified a special break-in oil for the first 500 miles that contained additives not found in normal motor oil. This oil was so expensive that many dealers skipped it, leading to premature cam wear. Cars that received the proper break-in oil showed significantly less wear even after 100,000 miles. The engineering drawings for the Super Duty filled 47 boxes when the program ended. Instead of destroying them as ordered, Pontiac engineers microfilmed everything and hid the films in the archives labeled as obsolete transmission parts documentation. These films were rediscovered in the 1990s and became the basis for the reproduction parts industry. The dynamometer testing revealed something unusual. The Super Duty made its peak horsepower at 4,700 RPM, but it maintained 90% of that power all the way to 6,000 RPM. This incredibly flat power curve was achieved through careful cam timing and port design. It meant the engine pulled equally hard across its entire operating range. Here's secret number 17. Pontiac created a special tool room just for Super Duty production. It contained over 200 specialized tools and fixtures, many of which were designed and built in-house. When production ended, these tools were supposed to be scrapped. Instead, they were sold to former Pontiac engineers who started their own performance shops. The Super Duty's connecting rod bolts were manufactured by ARP, but to specifications that exceeded even their racing products. They were rolled thread instead of cut thread, shot peened, and tested to 220,000 psi. Each bolt cost Pontiac $12 in 1973, roughly $80 today. For comparison, standard rod bolts cost 50 cents. The real reason for the engine's 8.4.1 compression ratio is fascinating. It wasn't just for emissions. Pontiac discovered that lower compression, with the huge ports and aggressive cam, actually made more power on pump gas than higher compression would have. The engine was optimized for velocity and flow, not compression. Secret number 18, 20 Super Duty engines were built with experimental plasma-sprayed cylinder bores. This NASA-derived technology eliminated the need for iron cylinder sleeves, reducing weight and improving heat transfer. These engines made 15 more horsepower but were too expensive for production. They were all supposedly destroyed, but one allegedly powers a restored Trans Am in Japan. The carburetor calibration was so specific that Pontiac created 5 different versions depending on the destination climate. Cars headed to Colorado got different jetting than those going to Florida. The calibrations were color-coded with dots on the carburetor that only trained technicians understood. The Super Duty program employed 43 engineers and technicians full-time for 3 years. This was for an engine that would only be in production for 24 months. The program cost more than developing an entirely new car model. GM executives were apoplectic when they discovered the true cost. Here's secret number 19 that's truly shocking. Pontiac built 3 Super Duty engines with experimental variable valve timing. Using a mechanical system similar to modern VVT, these engines could change cam timing by 15 degrees. They made 340 horsepower at 3,500 RPM and 425 at 5,500 RPM. The system worked but was deemed too complex for the era. The Super Duty's pistons had a special coating on the skirts that reduced friction by 15%. This coating, developed for aerospace applications, cost $30 per piston to apply. It was one of the first uses of advanced coatings in a production engine. Modern racing engines still use similar technology. The final secret, number 20, is perhaps the most incredible. When GM ordered Pontiac to stop Super Duty production, they had already built enough components for the 1975 model year, approximately 1,200 complete engines worth of parts. Rather than scrap them, Pontiac sold them through their parts network over the next decade. You could literally build a brand new Super Duty engine from parts until 1985. The Super Duty's influence on American performance cannot be overstated. It proved that engineers could meet government regulations while still building serious power. It showed that there was a market for expensive, high-performance engines even during the darkest days of the muscle car era. It inspired a generation of engineers to find creative solutions to regulatory challenges. Think about what Pontiac achieved here. In the face of strangling regulations, corporate hostility, and a market that was supposedly dead, they created one of the greatest performance engines ever built. They did it knowing it would lose money, knowing it would anger their bosses, knowing it would only last 2 years. They did it anyway because they were engineers, and engineers solve problems. The 455 Super Duty wasn't just an engine. It was an act of defiance. It was a statement that performance would not go quietly into the night. It was proof that with enough creativity, determination, and slightly flexible interpretations of the rules, anything was possible. Today, a numbers-matching Super Duty Trans Am can sell for over $200,000. The engines alone, if you can find one, trade for $30,000 or more. But the real value isn't monetary. It's what the Super Duty represents. The last stand of the muscle car era, the final thunderous roar before the silence of the mid-70s. Every time a Super Duty fires up, it's a reminder of what American engineers can accomplish when they decide the rules are more like guidelines. It's 455 cubic inches of pure, concentrated rebellion. And 40 years later, it still makes everything else look slow. What's the most impressive engine you've ever encountered? Drop a comment below and share your story. And if you enjoyed this deep dive into one of history's greatest automotive rebellions, hit that subscribe button for more stories of engineering excellence and corporate defiance. Until next time, keep those engines running. And remember, sometimes the best engineering happens when someone says it can't be done.